everybody, my name is Peter Klapper from the School of Biosciences at the University of Kent, and in this video clip I want to show you how we can compare data using a t-test in Excel 2010. Now the first thing is that we need to have some data, so I did a little experiment and I grew some colonies, some bacteria on agar plates under a certain condition. Let's call this condition 1, and I repeated the experiment also under condition 2. So I had two independent experiments and I simply counted the number of colonies on my plates, and these are the data. And in the next step I did a little bit of descriptive statistics, so you can do that in Excel 2010. You just simply go to the data tab and you find a data analysis tool on the right hand top corner. You then just simply go to descriptive statistics and you can input your data range here and so on and so forth. So I have done that already. And I found that my average colony number for condition 1 is 168 colonies per plate. I have a certain standard deviation, and I can do that also for condition 2. Get a mean of 221 colonies, and again I have a certain standard deviation. And of course I want now to compare these two conditions and say, is there a significant difference between these conditions, between condition 1 and condition 2? Or are these different numbers here and the different means, are they just simply due to simple standard error? So I need to formulate my null hypothesis. So the null hypothesis is there is no difference between the means of the data other than simply due to sampling error. Or I can express that as the two samples come from the same population. This is basically the same thing. So it would be the means of the two samples are exactly the same. I can formulate an alternative hypothesis. So the alternative hypothesis, I would say there is a significant difference between the means of the data. So the mean of sample 1 is not equal to the mean of sample 2. And this is caused by other influences than just the sampling error. Or in other words, the two samples do not come from the same population. So how am I going to do that? In this case, I can use a t-test, and Excel has a special function for a t-test, so I can compare these data with this t-test. We go to data analysis here, and now we go to something that is called t-test for two samples. So we have two different samples here and here, and these samples are independent of each other. It's not like before and after. It is I've done these samples actually at the same time, but grew the bacteria under different conditions. So we would use a two-sample t-test, and we would assume, usually we don't know about the variances. In our case, we know the variances because we've done the descriptive statistics already. So we've got the sample variance here, 1,579, compared to sample variance here. And the equations for these t-tests are slightly different depending on if we know the variance or if we assume they are unequal. Anyway, we have unequal variances here and two samples, so we just simply click OK. Now we put in the variable number 1, so that would be this one here. We put in variable number 2, so that would be this one here. And for the rest, we don't have to really worry about. we don't need to do a hypothesis mean difference, because we say there is no difference. That is our null hypothesis. And we use a critical significance level of 0.05. This is quite common. This is a 95% significance level. So we don't need to change this. And we want our data to be shown, say, here. So all we need to do is click OK. And here we get our data set. And we get the two different means, we get the two different variances. Here we've got 7 and 9 observations, so that's always good to check that you've got the right number of observations. And now here comes the very interesting bit. We get a probability here for a two-tailed test. Two-tailed means when we say there is no difference, and in the alternative hypothesis is there is a difference. This is basically what a two-tailed test says. And the probability for this to happen is 0.01. It's this number here. So what does this actually mean? So our p-value was 0.01. But the critical significance level, alpha, is 0.05. That's 95%. And we know that if the p-value is smaller than the critical significance level, it is very unlikely that this result occurs just simply due to sampling error. Or we can say that with this famous mnemonic, we can say if p is low, h0 must go. Or in other words, we therefore reject the null hypothesis and accept the alternative hypothesis. So h0, we cannot support h0. So let's go back what h0 and h1 were. So h0, you just see it here, there is no significance level, but we said we can't say that, so we have to use the alternative hypothesis, h1. There is a significant difference between the means of the data, and the two samples do not come from the same population. Or in other words, I can say, after I've done my experiment, there is a significant difference between condition 1 and condition 2, and this is at the 95% significance level. So I hope this makes sense and you understand how you can do this t-test in Excel. Thank you very much for watching.